start with this. Let's start with this topic. Previously, uh, we were here previously at this slide, and we discussed this diagram and these points. These points are rewritten here, nothing else. So that's why I said to you to read it by yourself. Because if you will see that here, first step is what? Prepare an agent with initial set of strategies. So this is just prepare that agent with the initial set of strategies, that if you will be in this position, what action you will take. Okay. So then step two is observe the environment and its current state. So this is now observe. This number one is written here. This number one, observe the environment and its current state. One is that, other is that. Select the optimal policy regarding the current state of the environment. So now here agent is seeing that here it is a fire, and here on the other side the agent has the water. So these just select the optimal policy regarding the current state. So after observation, whatever the states of the environment the agent has observed, select the optimal policy according to the set of strategies that is already given. And the agent is selecting this fire, which is not a good action here. The agent must have to go to fires with this water, then it would be optimal policy. So first the agent should have to move towards the water. So anyhow, step three is what? Select optimal. Whatever the optimal action the agent has, it has taken, but it is going to the fire, so which is not good. So step four is what? Agent get reward or penalty as per action, which is mentioned here. So all the steps just are mentioned here with just further explanation. So that's why I said it to you to just read it and then you will understand. So now this topic is now finished. So the types of machine learning algorithm. So you have supervised first, unsupervised second, semi-supervised third, reinforcement last one. So in the supervised, you have further categories, the classification and regression. And in unsupervised, you have four subcategories: clustering, association, dimensionality reduction, and anomaly detection. With semi-supervised, you don't have further subcategories. You have only the difference that you can start with the labeled data or you can start with the unlabeled data. These are the two approaches discussed here in this point. And then reinforcement is totally different design. So it is reward based, which is also here it is an explanation with example. So this is the end for the types. And now, if you have a task with the data or something, and you want to decide that which category is good for your task or problem in machine learning, how you can decide. So then this short diagram is giving you an idea that if your data is correlated or redundant. Correlated means if you have some relationships with some columns or with features, you have the relationship. They are similar to each other. They have some relation. So that's why correlated. Are redundant. Redundant normally means repeated. Okay. If you have some features, if I say features, then I have given you the understanding what features means. Okay. Initially in the beginning, I have given you that if you have a table with rows and column with full of data, then the column headings would be called features. Okay. This is the understanding which I have given to you. But when I say, and when I didn't see any response on your faces, so that's why I say this definition again and again. Just for beginning to understand the things, okay? So whatever data you have, that data would be in a tabular form. So then you have to check that if the data is correlated, how you can checking the features. If there is a relationship with the features, or if there is any any features which is redundant, which is kind of a repetition, then what? If the answer is yes, then you have to reduce the, then you have to apply the what? Dimensionality reduction. Because features are very much similar to each other, or the repeated data is there in the features. So then what? Reduce the dimension. This is what we learn when we study this dimension reductionality. And after that, we will come here. But if your data is not correlated, not redundant, if the answer is no, then you have to do another question. Then you have to find the answer of another question from your data. That is data, is our data is producing some kind of a category? Category mean class, classification, this group and that group. So is our data is producing some category? For example, if I will give you mails, so some mails can be spam, some cannot be spam. Two categories, huh? Two categories. So if data is producing any kind of a category, if yes, if the answer is yes, then you have to check one other question. But if so, what is that question? Then you have to check that is the data is labeled. So your data is producing category, yes. And if your data is labeled, then it is supervised learning, okay? If the answer is yes, then you can apply some supervised learning technique, which is classification. And if your data is not labeled, then you can apply some clustering technique, which is mentioned here. And now I am coming back to here this question: is data producing a category? If yes, then this is the branch. And if the answer for this question is no, my data is not producing category. So then what? So then I have another question: that is my data has some quantity? Because continuous values, maybe I will go to check the continuous values. Classification, clustering gone. Regression is still remaining, huh? So is my data is producing some kind of a quantity, some kind of value amount is there. If you remember the example of house prices, then the house price is what? Continuous values. So if you have that quantity, then use the regression. If you don't have, then bad luck. You cannot do anything. Okay. So this picture is giving you an idea that how you can go on with the selection of different models. So this is dependent on your data. This is dependent on your data. So now moving next.
I want use text as an input. How can I produce an text word and text word or like which it will like
Again question. If you will,
I have a text and I want to generate based on this text. So here we are talking about generating numbers. Now how do I
that is totally a different model. That is n-gram model. Okay. You have a text and you want to predict the next text. For example, in the mobile phones, you have applications. You are typing one word or two word and next is predicted by the mobile phone. So that is not this thing. Okay. That is NLP. That is NLP. That is not machine learning. But people around us, they are mixing the machine learning, the big data, they are mixing everything. So behind that prediction actually, when you are typing and the next data is predicted, so that n-gram language model is normally used behind that technique. What is that? So you have to count unigram, bigram, trigram here. Unigram mean one word. You have to count the probability values of one word. I am giving the answer to your question. Okay. If somebody is not understanding, leave it. And you have to count the probabilities of two words together. Okay. And similarly, you have to count the three words together. And you have to store these probability values in just a file. And when you are typing, okay, one word, that would, this model unigram would not be helpful in this prediction model. But if you will use bigram, which is the probability values of two words together, for example, this is a car, so you will count how many, you have a big file in which you have this text is written, you will count how many times this is coming in this file. So maybe 20 times, huh? And how many total bigram? Bigram means two words. I'm not counting this as two words together. That may be 200. So 20 by 200, you will have the probability value. In this way, you will count, okay, this is one bigram, is A is another bigram, A bar is another bigram. So in this way, you will calculate the probability values for all the words and you will store it in a file. And now, if I am typing this, if the probability value in this file after this, the probability of is higher, that will be already there in my file. It will check the probability and it will predict the is after this. Okay, and you will find the probability higher automatically because after this the probability of is higher, not this a, because you will not see in English that this a car, huh? And is absent. No, in the text you will see always this is, this was, something like that. So definitely then you will have the probability of this a higher than this and a. So that is separate model, okay? So that is not machine learning. That is NLP. Anyhow, coming back to this topic, methods based on learning. So this is not difficult. These are different categories that you can use for training or for learning. One is called batch learning. Other category is called online learning. Another category is called instance based learning, which means example based. And another one is model based learning. And I have updated only the diagrams in it, nothing at, okay. In these slides, I have updated only the diagrams here. Why I have updated the diagrams? Because mostly the students normally they can learn better from the diagrams rather than the text, okay. Anyhow, what is batch learning? So normally batch, for example, you have the systems on shops, they are using those some kind of a machine like that. Yeah, they are, and then they are, the computer is connected, they are entering their values, and at the end when they are closing, they are doing all the transaction, and at the end when they are finishing their shop or what, at that time they will update in the system, and all the entries from the morning up to the evening, all the entries will be updated finally. So that is what, in one shift, from the morning up to the evening, all the entries will be handled. So that is called batch learning. Here the definition for the batch learning will be similar, but in some other way. Let's see that. So you have a machine learning model. You have a machine learning model, and you are studying what are the different methods that machine learning model can use for learning, for training. So if we have a model, we can train that model with the data. We can train that training is called learning, okay. So if we have a model, we can train that model with the data. If in one single shift, if in one single uh, activity, you can say, okay, or one single batch. Batch is normally a piece, huh? One single activity. In one activity, if you are going to get the training of your model, then this is called batch learning, or other name is offline learning. For example, if you will do image classification, then you can do this through batch learning. But this is not only that you can do only this image classification only with batch learning. This is not only example. You can do something online learning with image classification. But here it is just an example. Let's see this diagram. This will give you the flow chart for the batch learning. Okay, we are starting, we are getting, here my pen is disabled when I do zoom in, so my pen is now gone, okay. So So then I'm using this cursor now. Okay. So in batch learning, you will first get the data set for the model. Then you will give this data set to train your machine learning model. This is your model now. You have given this data set here. So now here the training is done, and after training, you are testing through some test data. Okay, you can draw something here, test data, some line here. Okay, here you can draw something test data and write test data here. You will give test data. You will test your model, and evaluation means its results. And if it is giving you good results, then you are pushing your model for production. For production. Production means you are deploying your model. Okay. You are deploying your model. And then your model is running on production without learning. So that learning is already done. And now your model is running without further learning. Without further learning. Learning is already done here. And if during testing and evaluation, when you tested this model on the test data, if it is not giving you good results, then you are going back again and you are enriching the data. And then you are coming again for the training in one time, on training only one time. And after training, again testing. If results good, then on that side. And then you will not come back here. And if results not good, then okay, you will do something again with the data set, enhancement or enrichment or whatever. So this is the normal diagram for your machine learning model, especially in the supervised learning category. So that's why it is written here. Image classification. You can give images, some images of cats, some images of dogs, some images of cows, and then you can also provide labels in the data set. Your model will be trained on it, and then you will give some images without names, huh? And then your model will automatically detect that this is the cow, this is the cat, this is the dog, or whatever. We already have seen this thing. So this is batch learning. And now, what is the other name for this batch learning is what? Offline learning. And now, what is online learning? So when you do this training in multiple batches, in multiple pieces, okay? In multiple batches or multiple pieces or multiple increments, one time and then second time, third time, you can do at any time in multiple pieces. When you do this training, when your training is do this training in multiple batches, then this is called online learning. Online learning. For example, the example is here medical monitoring system, because that is very much sensitive. So that's the reason. Yes.
So the batch in online learning, it's the same in batch learning, the same batch.
What is your question? Your question is batch online learning is the same as the batch learning?
The same individual batch.
Have I given you any definition for the batch online learning?
No, I mean the same algorithm.
No. Here we have taken the definition of batch learning. What is batch learning? I told you that when your machine learning model will get training only once, and then it will run on the test data, okay? Then this is batch learning. And online learning is what? Your model will train in many steps, okay? First step, second step, third step, before testing. Before testing, okay? Before testing. So your model will get training in multiple batches. Batches mean piece, or batches mean a step, okay? You can, so I'm giving you these different words just for understanding. Otherwise, batch is a group, okay? You normally use this word He's my batchmate. What it means? He's your session fellow, huh?
This means it's the online learning. Instead of using the whole data once, we separate it. We train the model on a small piece of the data.
No, no, no. We will not separate the data. Okay. Batch online learning is not a term, okay, which you were asking, okay. What is Abdullah? Batch online learning. This is no any term, okay. So that's why I'm not answering that thing. We have only what are the terms we have available? Batch learning, separate. Online learning, separate. Batch learning is also called offline learning. Offline learning, and then this is online learning. From the name, you can understand it is something you can get it whenever you want. Okay, that is something online, huh? Always online. So you will get the training of your model in multiple steps. How? The example is medical monitoring system because it is very much sensitive. So that's why you want to check it again and again, so that your model will give you an accurate thing. So from this diagram, you will understand finally what it means, where those increments are. So start data set, very much similar to the previous diagram. Here we are getting training, and then we are testing. Testing, you can build something here with the test data. Okay, you are testing on a test data that is same, and if it is good result, push to production, push for deployment. Okay, and now your model is running and it is deployed in the company or in the organization with this data. And if you have more data, if you have more data arrived, then you can do this on this when during the running of the model. Okay, during the running of the model, you can do this. You can, for example, here these are the mini batches, and these are the small portions of the data, and you can give these portion of the data here during the running of the model. And here what you are doing, you, for example, if it is yes, okay, your model is deployed and now you cannot train it further. And if you have to train, you have to stop this and you have to build it again. This was your old data, then you can mix the new data in it and you will give it again. So this is something different. This is something different. Here your model is in a running position. You will not stop it, and during that running position you can give some more data to it, and it will learn, and it will learn from that. So that's why medical monitoring system. So maybe they have your first CT scan of your knee, and there are different aspects, reading first image and then second image, and in that CT scan you have, normally in MRI you have maybe 40-45 images on one large X-ray. And if your machine learning model is reading that to identify the problem, it will not identify from the first image. Okay, it will read all, huh? Maybe. So that's why it needs real time. So that's why here it will work more. So, or maybe first it is reading the old MRI report and now you have the updated ones. So then you can give that updated ones at the running time. And then it will, your ML model will predict something better. Anyhow, this is online learning, but this is definition. This is just a definition. You don't have to go in deep. The things that you have to do in deep, that is the coding, okay? I want that you there at that time, you, I will be happy if you will go deep there, okay? Instance based learning. I don't want to make you teachers. I want that you will initially will do some development and then you will own some company. And don't be poor like your teacher here. Okay. So anyhow, instance-based learning. Instance normally mean example. Instance, piece, example, piece. For example, there are many pieces of something and you can get one piece from that. That piece. Piece is not for Aman, huh? So instance-based learning. What is this? So you normally in this kind of learning, you will store some training examples. You will store some training examples already in the memory. And then one new example will come or new problem will come. You will compare that new problem with the stored examples. With the stored examples. Why you will compare? To classify them. To classify them. So that is called instance-based learning. Again, instance-based learning is what? IBL. You will do what? In your training data, you will keep some examples of the data here in the memory. And when some new problem will come, or when some new example will come, you will compare this new with this stored one, which you already stored in the memory. Why you do this comparison? To classify them. And this example is here, spam filtering with new email. You already have emails. You already have emails. Some are what? Spam, some are not spam. And when you have a new mail, you have to check that it is spam or not. You will compare with those ones. If it is whatever the category it will match, you will give that answer. So, so that's why you have a new example here, and here these are the stored ones. And after comparison, you are you are calculating something. Distance or criterion of choice, you are calculating something. You can calculate Euclidean distance or something like that. There are different formulas, but you are generally you are comparing it and giving your decision that that email is a spam or not. Model based learning. So in the model based learning, you can guess from the name model based learning, it means that you have a model already. So this in this kind of a learning, you will build a mathematical model or you will build a uh, machine learning model. Machine learning model is a mathematical model, okay? So you will build a model and that will do what? That can predict outcomes. The other names for outcome is dependent variables. Why we are studying these different definitions? It will give us understanding of different categories and it will also give us understanding about different terms that we will see in this course. So what is dependent variable? Your output of the program is dependent variable. And what is independent variable? Your input of your model is your independent variable. Okay. When you will see these things, what is dependent variable in my model? The output of my model is dependent. And what is independent variable? The input of my model is dependent. So in this model based learning, I will have a model. And that model will predict output based on input. Or I can say that model will predict dependent variable based on independent variables. So that would be called model based learning. That would be called model based learning. And these model will be trained on large data sets, not small. Uh, and it will get training on large data sets, and then you will provide them the new data and it will predict. And let's have a look on this picture. This is the normal diagram of machine learning model that you have already. So here So it is not different. It is not different from this. Okay. Because we only, our focus is on model based. Model will learn. So this is our model. This highlighted with these dotted lines. And okay, COVID-19 data. First, we are pre-processing the data. Normally, this is the first step that you normally do for all of the machine learning models. You will process the data. Process data can contain data formatting, cleaning, transformation, reduction, sampling. We will discuss these things in detail in the next CLO. And then after pre-processing, okay, we have the data. We are calling it, now our data is more matured, more enriched. And we divided this data into two things, training and testing. Training and testing. Testing is something that we will use this data during the evaluation at this stage, at this pink stage, testing and evaluation. Okay. Uh, in this is the testing and evaluation. This is the stage where you can test the data which you already have separated from the original data. Okay, now coming back to this model. So you divided this data into two things, training and testing. And on the training data, you have trained your model, machine learning classification model. You have trained your model on this training data. You have kept this test data aside. Okay. And you have trained it. Okay. This is candidate model, classification training model, and here model evaluation. Model evaluation means you are evaluating, and if there are some features or parameters you have to change it or update it, you can also do hyperparameter tuning. Leave this. Okay, this is a diagram. This is not exact diagram of this one. I have taken something, I have copied something to give you an idea that this is the model that will get training from here. And here you are giving test data, that test data. So what is the definition? This is a mathematical model that can predict the outcomes, that can give us output based on input. So here, so this was the training data, this was its input, or also this testing data is also its input, but this is the feedback data. So our model predict based on this training data. Training data is our actually our input to the data on which this model has got the training. So this model now is getting training, and during training, if some parameters should be, you have to adjust, then this is called evaluation. You will check this model that it is performing good or not. That is called evaluation. If it is not performing good, then you can set some parameters. So that is called hyperparameter tuning. You will tune, you will set different values for to those parameters. And then here your model is what? And when it will be okay, your model now is ready to predict. You will give the test data and it will predict the output, and it will predict the output. It will predict the output. So this is what, so of the concept of this model based learning is existing in this model, because that model is taking input here, processing. Now learning is complete, and then you are giving some input again, which is through test data, and then it is predicting this input based on that inputted data already, which is it is giving the output based on that input data. So this is what it means. Now this is the end of CLO1, and now we can move towards CLO2. And inshallah, no, CLO1 was totally theoretical. This CLO2, now the things will start. Okay, the practical things will start, and At some point, when I will see that we have done something within the slide, then I will stop and we will do something, a kind of a practical, huh? So I don't know if something is available here or not. I don't know. I will check. I even don't know what are the passwords for that. You know that? Do you know the passwords of these computers that you have in your lab? Okay. If you know that, then we will see what is available there. Is the Python available there? Huh? I think, yeah, I think, let's see. I hope that will be available. If not, then from the next class, if you have the laptop, take your laptops always with you, okay, in which the Python is configured. Because I will not teach you how to configure the Python there. So now CLO2, let's see that. This is 1.2. In the document, CLO 1.2 is what? Understand data preparation. In this CLO, we will learn how we can prepare the our data set, and how we can and feature engineering. Understand data preparation and feature engineering through stats and visualization. First, we will understand what is data preparation and what is theoretical engineering, and then whatever we will understand here, we will try to understand these two topics through stats and visualization techniques. And then whatever we will learn here, we will use some tools and techniques, whatever we learned in this CLO, on some given task. We will take some problem and then we will apply those techniques over it. So this is the practical portion. And we will do some of the assignments. And after doing some practice, I will assign some practical assignment to you. Okay, that would be my simple strategy. So moving on. So data preparation, huh? So what it is, if so from the very beginning point, if you are going to build some machine learning model, okay, but that machine learning model will take some data and it will process. So the first step is always data, okay, and then is from where you can get that data. Okay, you can get this data from different websites, Facebook or whatever, social networks or whatever, different sources, or maybe the books, and you are using OCR and then converting those uh, um, uh, book text into editable text. Huh? So you can use different things. So what is data preparation or data set? So the process of collecting, first collecting the data, and then cleaning the data, and then arranging the data, and then pre-processing the data. These all words. You can write some more words, okay? This is definition. You are going to understand what is data set preparation. So you can say the process of collecting, cleaning, managing, or organizing, filtering. You can say filtering. Huh? You can use some other words. Huh? So that's why, but here in the definition, it is general words. So that's why we are using pre-processing data. Why we do this process? To make it more suitable for your model, this is the model, for the training of your model. You will give this data as a training to your model. So that's why the process of collecting, cleaning, organizing, pre-processing, why you are doing these all stuff, to make it a suitable data. For what? For the training of your model. And this process is called data set preparation. But for this, you have to take care of the quality of the data set. When I say quality, it means, for example, we have students which are getting good grades, and some are which are taking average, or some are which are very low. So you can say these are quality students. These are not. This is just an example. So your data must have the quality. When your data must be quality, if it is relevant. If you are going to run a machine learning model on cancer disease, then you must have to collect data related to cancers, not the diabetes and not something other. Okay, so you have to collect the related data. And if your data is not related and it is mixing with others, then the quality is also down and it is not relevant. So you have to collect. So your data must have the quality and relevance of your data set or data directly. So if you have a good quality and relevant data, then the performance and accuracy of your model would be good automatically. So this is theoretical concept. I want to get rid of these theoretical talks. I want to go fast from there. So what are the steps involved in preparation? Let's see that one by one. Number one, data collection. So the people who are studying this machine learning after AI, then they already know what is data collection. They already know. Maybe you have heard this name already in other courses. Okay. So what is data collection? So you don't have data, you have to collect. You don't have data, you have to collect that data. You have to gather that data. From where? From different sources. Those sources can be what? Databases, can be APIs, can be files in offices, huh? Can be web scraping. So those sources can be libraries, physical libraries, and then I told you, then how you will convert that bookish data into editable data, that is another question. But this is a this is a strategy that you are applying to collect the data. So now whatever the data you will collect, we already said that it should be relevant to your problem. If you are going to build model on cancer, your data must be related to cancer, not to some other disease. So relevancy, data collected should be relevant to your problem that you are going to solve. And your data should be from the real world, not a data that you normally, people are doing what? People are also creating the data at their homes, huh? By writing by themselves or something like that. Or by writing some, now you have the chat GPT there, huh? So you can give him a query and he will give you something, some para. You can copy that para there. So you don't have to use artificial tactics, okay? So you have to collect real data so that your model will give you good results. And this picture is just giving you the idea of different sources. So you can collect data from websites, you can collect data from IoT. Here IoT means different sensors. Sensors is reading something, and those sensors have whatever it is reading, it is data. Huh? So databases, that is databases, purely databases. These databases can be databases in your computers or physical databases like libraries. Business systems, okay. In companies, you have these business system, paper documents. Okay, this is covering your paper. And then from these all sources, there would be the question, what to collect? I want to collect only cancerous data, okay? Where to collect, from where you have to collect, and how to collect. So you have to answer these questions when you are going to collect collect data from these different sources. And then there are different data collection methods are available. You can collect through APIs. You can use some APIs. You can use OCR techniques. On the paper, you can use OCR techniques. Or you can use some APIs which will give you or robotic process automation. This robotic means you studied AI. So it can be physically a robot or it can be your program, okay? Intelligent document processing. So this can be again your uh, program or software that will process your documents, or web scraping. Twitter's data, Facebook data, fetching data from tweets, that is through web scraping. These are called web scraping techniques. So you have these different methods. You can use any different methods. And then how much to collect and where to store the data, our collected data, where to store. So there are different repositories. So when you will do some project, then your supervisor will give you the idea that how much data that you have to collect. For some models, you need maybe only 10,000 sentences. For some other models, you maybe only need for 10,000 images for classification. It depends. It depends what you are going to do. And then your supervisor can give you the idea that how much data you can get. Or you can read the literature and then you will see that how much data people are already collecting in this domain when you, or how much data people are already collecting with this problem or in this domain, then you will have that idea. And whatever they are collecting, you can take a little bit more than that and then you can go on, because that evidence in the literature is already there that people are collecting 10,000 or images or 10,000 sentences or whatever. So you can store the data in SQL, no SQL databases. That is, you can understand. You can store it in data warehouses, or you can store it in data lakes. So these clouds, or you can call them lakes. Okay. Otherwise, data lake is a another term. Behind this, actually, those clouds are the concept. Okay. So you can store your data in any format you want. You can store your data in any format you want. So when you have this data lake or data warehouse, it means we are not talking about format, okay? It is the physical environment. You can store it in files in on computers, whatever it is. So this is data collection. Now number two, data cleaning. You have collected the data. Now you have to clean your data. And this cleaning involves, you can read this text or you can read this diagram. You will have that idea. Why? That's why I am pasting these images there. That's why I am pasting these images there. So here, so if you want to do the data cleaning, so whatever the data that you have collected from different sources, now you have that data and there would be different things in that data that you should have to clean. And what are those? Error is general word. Okay, what kind of error? Let's leave it for a moment. When you will do some real processing, so then you will understand some missing values. So if that data, uh, sometime you have a text file and in the text file the things are going on, the data is written in English or Arabic, and but sometime some machine language is going on there on the line, huh? Some machine alphabets are going on there which you don't understand. So this is what this is. You can call it errors or you can call it something is missing there which you don't know, huh? Or outliers. Outliers normally means your data, whatever the data is, your all the data is on one side, but you have something in the data which is so much different from your data, okay? Which is so much different from that other data. And if you have something in your data which is so much different from your existing data, that is called outliers. You have to identify these things. You have to identify what is outlier there. So outlier is like a anomaly, huh? Rare event, okay? Which is different from your existing data. And then inconsistencies. So if your data is relevant, related to each other, that is also okay. But it depends what you are going to do. Sometimes you want to understand related, you want to do something which you will get good output only in related data or correlated data. But sometimes you are going to do something with your machine learning in which you don't want a related data. You don't want correlated things. But anyhow, here these are general words. Here these are general words, which is saying that whatever data that you have collected, if you will find something in your data which you think that it is not correct, then you should have to remove it. This is the general concept, okay? This is the general concept. If you will see that in your data something is existing which is a kind of error, then you should have to remove that error, okay? So you can use only one word for all these things. So in data cleaning, then what? You have to identify all these issues and you have to handle all these issues. Yes, this issue is a good word for all these things. Okay. So sometime you whatever the data you will collect from different sources, you will have issues in that data. And then you have to clean those issues. You have to remove those issues. Why? Because only then your data must be accurate and reliable. And what are the techniques available there? Imputation, outlier detection. We will do these different things. Okay. So what are the techniques available for data cleaning? Imputation, outlier detection, removing duplicates. Outlier, I already given you what is outlier. Duplicates, you understand if something is repeated, then it is removing. Commonly used in the steps. So here you can see, if you can also keep this figure in your model, in your mind, that if you see, if you have your data, you want to remove unwanted observations or you want to remove issues. First, what you will do, you will fix these issues or you will fix these errors, and then you will organize them or you will manage unwanted outliers. So this diagram is giving you an idea that for data cleaning you can do what? You can remove general issues, you can remove structural issues. Structural issues means some document is related with other document, but it is existing somewhere, so you have to move it from that space to other space, and now structurally they are aligned, they are in one space. So that's why it is called structural errors. This can be a document in your data, or this can be a paragraph in your data. Paragraph would be on a wrong position, okay? You have to move it into the relevant position where you will have the similar data like this paragraph. So this is what? This is structural errors. And managing unwanted outliers. So you know that what is outlier. So outlier, if you will have outliers, you can fix it through. So this structure and outlier and this structural example and outlier example can be the same, which I have given to you. You can use it for both of these things. Ah. Handling missing data. If there is so this is just repetition. So if there is something missing in our data, you have to fill it. And there are different techniques to fill that gap. And there are different techniques to fill that gap, which will increase the size of your data. So this is one data cleaning. And now data integration. Normally means you have a bigger things and then you are moving that bigger thing into smaller thing. You are contracting it. In mathematics, you have a concept of derivation and integration. You have a concept. Derivation is what? Breaking one thing into different parts. And integration is putting different parts into one thing. So this is integration. So here, data integration. So when you will collect the data, maybe you will collect the data from the different sources. So that's why, no doubt, this is the different parts. So these are the different parts. You have to make all these different parts as a one data set, as a one data set. So this diagram is giving you that idea. This diagram is giving you that idea. So whatever you will collect from multiple sources, you have to make it a single data set. Single data set. And when you will do this, this will involve what? It will resolve inconsistencies. So when you will make it one data set, then inconsistency will be removed. Because during this process, you will see that this data, it should not be the part of the data set because it is totally irrelevant. Then you will remove it. So you will see different issues. You can observe different issues, and then when you will do this integration, at that time you can perform these operations. So in this way, you can remove inconsistencies in data formats. You can have one data in textual format, another data in audio format. So this is not the way. This is not integrated. So you have to convert that audio format into textual format. Into textual format. So that is in this way. Okay, you can. This is what you are removing inconsistency because the data were inconsistent previously, and now after doing that, it is consistent. So attribute naming conventions. Attribute naming conventions. If you have some tables there, attribute is a word that you will use also for features, for column headings. Okay, now this is a new term. Attribute, feature. If the feature, I have given you the definition. What is feature? If you have a tabular data, then the column heading is called feature. Huh? I'm not giving you the actual definition. That will come. But this is for understanding. An attribute is again the column heading. Okay. Attribute can have values. Attribute is a variable. Feature is also a variable. Okay. So normally in programming language, you have the variables which can take multiple values. Huh? So attribute naming convention. So in the data, you will have some tables where the names, the data is relevant, but their names are different. So then what? You will give them the same name. Huh? And similarly, you will have other issues. And in this way, you can do what? You can do this data integration. Moving next to number 4. Feature selection of oblique feature engineering. We already know what is feature. So if our data is not in a tabular form, it is a textual for paragraphs and paragraphs or something like that, or if we have read some data from some source where the data is in a file, but the values are spaced with a tab. This value, then tab is pressed, then another value, then tab is pressed, then another value, but there is no headings. And then in the next line, you have again the same value, then space, then tab, another value, then tab, another value. So if you have one value, for example, one value here, then tab, another value, then tab means space, okay? And then another value, and then you have the value next, which is, for example, here 25 is written, and here, for example, 37 is written. So the data type is same of this column. And then tab, and then you have this, and then tab, and then you have this, and you don't have the headings for that in that file. You have some document where you don't have heading in that document, but you have something like that. So then what? You can convert that data into features. You can you can name some features here. You can name some features here. You can name some features or attributes here. So so you can create your feature, or if the features are already available in your data set, then you can also select these features. Then you can also select these features. Or if you have data into the form of features, into the form of columns, then sometimes this situation can happen that not all the features are helpful to your model. Not all the features, not all the columns are helpful to your model. Then you have to do what? You have to select. You have to select features. And then what approach you have to use here for the selection of features? Here you have to keep only the important features, and then you can throw the other unimportant features. Previously, we have seen some example here. Oh, that is not that CLO. For a normal, I don't know when we were seeing an example. There was a house, number of rooms, number of bathrooms, huh? Price. There was a picture there previously, if you remembered or not. So there were five features there, but we dropped three of them and we have taken only two and we renamed them. So that is the example for that is the example for that feature selection. So what is feature selection? We have sometime it can happen that not all features are important, or not all features are helpful to your machine learning model, are relevant to your machine learning model. Then what? You have to select important features. How you can do that? Identifying only important features are the feature which is giving us more information, or which can give, or which can contribute to your prediction, or which can contribute to your model. So finally, the term feature engineering, what it means? Creating new features, like this example. Oh, creating few here. This was an example that we were saying we are creating new features, or transforming existing ones to new ones for the betterment of our model. Transforming means changing. Okay. I think Arabic word is tabdil, maybe or baddil, huh? Something like that. So transforming existing features, whatever the features you have, you are changing them into new ones just to improve the performance of the model. And here you can do feature creation. This is just a diagram to keep this whole story in your mind. You can do the feature creation. You can encode features. You can extract features from the data, feature selection, and you will see in the second part of this CLO, you will see we will do these things. Feature engineering is what? Feature engineering, here it is written prediction engineering, or feature engineering is what? Taking only the important features, or creating new features. So everything that you will do with the features, that is called feature engineering. That is one term. Feature selection is selecting only important ones. But feature engineering is what? Everything that you will do with the features is called feature engineering. So you can also select these features automatically through some code. Anyhow, moving to next, which is data transformation. So what is data transformation? When you normally have, I'm giving you easy words, when your data, you converted your data uh, into features, and those features are the names, alphabetic names. Okay, this is called nominal. Okay, in English it is called nominal. If those words are nominals, are names, then you can, for example, this column heading and it has data. It can be integer or any kind of data. This column heading, it has data. This column heading, it has values. So you can convert this one column with that name, whatever. You can convert that column into one array, into one vector. Okay. I am using first the word array, okay, for your understanding. And then I am using the proper word vector. So you can convert this, you can convert this one column with all these values into one array with all these values. Or if you want to convert only one value and the name with the vector, you can also do that. That is not an issue. So convert when you convert your features, which is mentioned here, categorical variables, the in your data, whatever the categories that you have, the columns that you have. So this is one variable which has the name, this is one feature which has the name, which is one attribute which has the name, feature, attribute, variable. I am calling them the same thing, okay? And it has values. So when you have categorical variables, and when you can convert them into one array. This is one array, another one is second array, third array, fourth array. Now, proper word. You can convert these columns with headings, you can convert these features into one vector. And when you have only one vector, one dimensional vector, you can call it one hot vector. Okay. In machine learning, you can call it one hot encoding, which means one vector. One hot encoding means one array, one vector. So you can convert these categorical variables that you have in your data. You can convert them, which means you can encode them into numerical representation, numbers into numbers. In the data, you have nominal data. Nominal data means text, okay, nouns. You have some column which has noun values, nominal values. Nominal mean noun in English. And you can convert those nominal values into numerical values. And when you are doing some transformation like that, this is called one hot encoding. This is called one hot encoding. Moreover, you can also do further data normalization, or you can also do scaling in it. In databases, you have studied data normalization, huh? Data that is different. That is, but here it is some kind of a different. If you are balancing the data it can be different actually. Data in machine learning, L1 normalization, L2 normalization, these are the two techniques. When it will come, we will see what it is. The thing is that it will balance your data. It will balance your data. And scaling is something related to the size of the data. Okay, size of the data. If in your data, if you are collecting a data set that will have news data, sports data, entertainment data, and similarly other kind of data, and if all the kinds have a same size of data in it, then it is good. But if sports data is the size of the sports data is larger than the news data, then your model will predict, even you will give news data, it will predict sports data, that it is related to sports, huh? Because your data is your sports data is large in amount, and the probability value would be higher for the sports data. Anyhow, so scaling is something about the size of the data, about the size of the data. And if all the features have similar scales, which it means that if all the features will have similar amount of values, this is the meaning of this sentence. If all the features will have similar amount of values, the size, huh? I told you what is feature? A column heading. And column normally contain values. And if it is containing 400 values, and if all features are containing 400 values, that it means that all features are have the similar scales. And if you have these things, this can improve the performance of your model, of your algorithm. I can say call it model, algorithm, whatever. And now you can see the things here. Techniques for data transformation. What are the techniques? Number one, you can transform through categorical variables. That is what you can convert the categorical label into one hot encoding. Either it is a nominal data, either it is a ordinal data. Nominal, for example, so algorithm is what kind of a word? It is a nominal. It is noun, huh? Your names are nominal, huh? But it is proper noun. Proper noun also nominals. It is noun. Then it is proper. Ordinal. Ordinal is always nominal. For example, if I say in English, it is 3 times then this thing, then this 3 times is what? Ordinal. And if I will say, give me 3 bottles of water, then 3 is cardinal. This is English, huh? This is English. 3, 4, 5, fixed number, whole number is cardinal, huh? But if you will pronounce this number in other way, for example, I am 3 times senior than you, 3 times. So this is not a number, this is 3 times. So 3 times is then ordinal. Similarly, in Arabic, you will have words something like that. Talata marar, mara talata, maratain. Maybe in Urdu, I know many words, but you will not understand. So that's why I will not give you the examples for that. Yes, first, second. I am first. So first, second, third. So this is again, this is not cardinal. This is ordinal. This is ordinal. Okay. So you can also transform your data through min-max scalar, which is a normalization technique. You can, because when you are adjusting the size of your data, that is, you are normalizing actually. Then you can also use standard scalar. Standard scalar is also for adjusting the size, or other scalars for adjusting the size, which has max, ab scalar, robust scalar, power transform. These different techniques are available in different libraries. different libraries of Python, huh? And then you can use them for your machine learning purpose. And we will use them. What is data splitting? This is easy name. What is data splitting? What is data dividing? So that is easy. Normally, whatever the data we will collect after doing all that thing, after doing all processing, cleaning, integration, all that, and if now the data is ready, we will do the split. We will split it into training or the test set. These are the two popular one categories. You can also introduce this, you can also do another kind of splitting, or you can also do third kind of splitting, which is called validation set, training set, validation set, and the test set. Test set is normally you use when your model is trained. Training set that you will use to train your model on this data set. Test set that you will use to test the results of your model on that data set. And this would be after training, huh? And validation is the data set that you will use during the development of the machine learning model. If you were checking your model is getting training something, but you are not getting good evaluation results, then you will train some you will tune some parameters, and then you will give this validation data as a checking to validate that now the results are coming good or not. And when you will see finally on the validation data it is giving you the good results, then you will go with the test data finally. So this validation data normally you use during the development stage of your model. Actually, development is done, but you are now checking. Before testing, you are checking personally. A programmer is checking actually personally with this data that it is doing good or not. If it is not doing good, then you are tuning your parameters there. So this is the division. This is the splits of the data that you normally do here in this part, and it is explained here. So training data. So what are the standards for the for the division? So this, so you can do the splitting like that: 80% training, 10% test data, and 10% validation data. These are the colors to identify, to understand these pictures. So this is one division that you can do. You can also do something like that: 70% training and then 15% test and validation. And you can also do something like that: 60% training and 20% test and 20% validation. So these are the different practices which people are doing in this domain of machine learning. Now, data augmentation. Augment. There is a medicine, there is a tablet, I think, that is called augmentin. Okay, what it means? You have something existing, and then you have something additional on it. That is called augment. Okay, if I will put something here, maybe some more border here, then I can say I augmented this screen. Okay, so you have extended something, huh? But you have you are taking the previous version and then you are adding in into it. That is called augmentation. So data set augmentation. So you have your data set, but the size of the data set is not too much. And then what? You want to augment it. Okay. You want to increase it. You want to extend it. So that is called data augmentation. It is optional. You don't, it is always better not to do that. But if your data is limited, you don't have that much data, then you can go for that. Then you can Go for that, okay? How you can do that? There are different things you can. So this data, how you can do that? This is basically normally people who are in computer vision, they are using this data augmentation. For others, it is not easy. But people who are related to computer vision, for them it's easy. What they are doing, they they are increasing the size or the diversity. Okay, let's see that. Let's see this picture. If you have this picture, and after that you can do what? Here we are detexturizing. This is the texture. These lines that you are seeing here available in this picture, but now here you are removing that texture, huh? Have you seen it? Now this is the original image, and here these lines that you are seeing on this orange color, these black lines, this is called a texture, and here that texture is absent. So you detexturized this image, and now you have another image, huh? And then here you decolorized this original image, and you have the maybe gray color or black and white or whatever you have. Now you have another image. Your data is increased, huh? Edge enhanced. So this is the original image, and then you have increased the contrast color of the edges, and you have this image, new image, which is different from that. Similarly, salient edge map. So you also, what is this technique? So you are using that technique, and you can convert this image into this way, or you are flipping or rotating and producing new images for that original image, and in this way you are increasing the size of your data set, huh? Yeah, we have one image, but now when you created these new ones, now we have what, 6 or 7 images for this, and it is increasing your size of the data set by applying these different techniques. These techniques, you can use some graphical software, or Python will do that for you. So why we use it? We want to increase the size of the data set. We want to increase the size of the data set, and we also want to make our data set, training data set, diverse. Diverse means which will have a variety. Okay. Diverse means something which will have a variety. So it will this is the variety, yeah, which we are creating. So you can use rotation, scaling, size increasing, size decreasing, flipping. So you can do this to increase the size, and this is normally the people who are related with computer vision. If you have a text, then this is useless, okay? Then you can do some other artificial things. But what I'm advising, if you want to get good results from your machine learning model, real results, then keep your data original. Original means with quality. Don't do anything artificial. When it is finished, okay. I was, I was looking at where it is going. So I will stop here after this, huh? Data balancing. This is also optional. It is not compulsory that you have to do this during the data set preparation step. Okay. During the data set preparation step, it is not compulsory that you have to do this data balancing. The other things are you have to do compulsory, huh? But this data augmentation optional, balancing optional. So if you want to do classification or maybe clustering or something like that, And if the data related to your classes is has different sizes, for example, spam emails are maybe 200 and not spam emails I have 500, huh? In my training data set. So then this is not good. You must have equal number of, maybe you will have 350 here and 360 here. It is considered to be equal, huh? It is considered to be equal. So so in such tasks where classes are imbalanced, you can apply these different techniques: oversampling, undersampling, generating synthetic samples. You can use these different techniques to balance your data set related to different classes. And so now you have understood what is imbalanced data set, huh? You have understood what is imbalanced data set. A data set in which your data related to one class is maybe 200 samples, and the other data which is related to some other class has maybe 400. So then it is not balanced. So in this situation, then you can do either decrease this class to 200 or either increase this class to 400. So that is oversampling and undersampling. Okay. One class is undersampled. You have to increase. So you will see here oversampling. Increase the number of samples of the smallest class up to the size of the biggest class. Okay. This is oversampling. Whatever the smallest class is, you have to increase its size to the bigger class. This is called oversampling. And and how you can do that? Generate synthetic sample from that existing data, copy paste some data more in that, okay, in that data. So that is called synthetic samples. Undersampling, decrease the number of samples of the biggest class down to the size of the smallest class. So if you have the bigger class, yeah, remove its samples and make it equal to the smaller class. This is called undersampling. And how you can do that? Simply deleting some samples from the bigger class. Class weight. So what is class weight? Assign a weight to each class. If you have two classes, spam and not spam, biggest class, assign some weight to them. How you can do that? Biggest class will weight have 1. Assign 1 to the biggest class. Smallest class weight would be what? How you can calculate it? Smallest class weight, how you can calculate it? Number of samples in the biggest class. You have to calculate how many data samples are available in the class. Maybe 200 images, huh? Number of samples in the biggest class, or in the biggest 400, huh? 400 samples divided by number of samples in the smallest class. Smallest class has what? 200. So 400 divided by 500, you will have this weight for the smallest class. You will have the weight for the smallest class. So biggest class, you will assign it directly 1. And I have already given you the example that the biggest class has 400 images, smallest has 200. And here you are doing what? 400 divided by 200, and you have the weight for the smallest class. Similarly, you have another technique that is called threshold. Threshold is also a term that we will use in different subjects: AI, machine learning, big data, whatever. So these mostly we have these terms in these subjects. You can threshold is some is if threshold is a variable that you can assign some value to it. It can be 5, it can be 10. It depends on the model. You will see. And if your model is predicting values between 0 to 20, if your model is predicting values between 0 to 20 and randomly, sometimes 0, sometimes 0.5, some point 5.10, from some point 11.5, but the range is between 0 to 20. and you want to set these values, and then you can say that okay, I am setting a threshold that if the value would be less than 10, I will call them zeros, and if the value would be greater than 10, I will call them 1. Okay, because in the next you want to classify, and if you have continuous values, you cannot classify easily. Okay, so then what, now I am creating my threshold 10, and then in my program, in my machine learning model, then I am checking if the model is giving me zero point 0.5 value, okay, make it 0. If it is giving me 11.5, okay, make it 1. So because now the boundary is what, the threshold is 10, and then you have generated zeros and ones, and then you can classify them easily. But these things are, which are zero, it is equal to some class, and which are one, it is equal to that class or something like that. So this is called threshold. You can decide based on the threshold. So if your model is predicting a value which is greater than the threshold, you can set it to 1, otherwise you can set it to 0. In this way you can balance different things in your data. So this is data balancing. And now from here, machine learning understanding data, we will understand the data with stats and with visualization from here. Okay. From the next lecture, inshallah. This is the code and also the execution. And we will execute these codes directly here. So come with your laptops, and uh, uh, mostly these things are copy. You can copy them. You can copy the code and paste in your editor, but it will give you the error. Why? Because sometime PowerPoint will present your code like that, and sometime like that another way. Huh? The PPT encoding was there, and if you will copy and paste them directly there, you will have many errors. So what you can do, you can paste first them in any text editor, huh? Like Notepad, and then from Notepad you can copy them there to your Python, and then it will work. Anyhow,
So, there are computers have Python and PyCharm.
I don't know.